Now that we've compared our model's loss curves on their own individually, how about we compare our model results to each other? So let's have a look at comparing our model results. And so I'm going to write a little note here that after evaluating our modeling experiments on their own, it's important to compare them to each other. And there's a few different ways to do this. Number one is hard coding. So like we've done, we've written functions, we've written helper functions and whatnot, and manually plotted things. So I'm just going to write in here, this is what we're doing. Then of course there are tools to do this, such as PyTorch plus TensorBoard. And so I'll link to this, PyTorch TensorBoard. We're going to see this in a later section of the course. TensorBoard is a great resource for tracking your experiments. If you'd like to jump forward and have a look at what that is in the PyTorch documentation, I'd encourage you to do so. Then another one of my favorite tools is weights and biases. So these are all going to involve some code as well, but they help out with automatically tracking different experiments. So weights and biases is one of my favorite. And you've got platform for experiments. That's what you'll be looking at. So if you run multiple experiments, you can set up weights and biases pretty easy to track your different model hyperparameters. So PyTorch, there we go. Import weights and biases, start a new run on weights and biases. You can save the learning rate value and whatnot, go through your data and just log everything there. So this is not a course about different tools. We're going to focus on just pure PyTorch. But I thought I'd leave these here anyway because you're going to come across them eventually. And MLflow is another one of my favorites as well. We have ML tracking, projects, models, registry, all that sort of stuff. If you'd like to look into more ways to track your experiments, there are some extensions. But for now, we're going to stick with hard coding. We're just going to do it as simple as possible to begin with. And if we wanted to add other tools later on, we can sure do that. So let's create a data frame for each of our model results. We can do this because our model results, recall, are in the form of dictionaries. So model 0 results. But you can see what we're doing now by hard coding this, it's quite cumbersome. Can you imagine if we had, say, 10 models or even just 5 models? We'd have to really write a fair bit of code here for all of our dictionaries and whatnot, whereas these tools here help you to track everything automatically. So we've got a data frame here. Model 0 results over time. These are our number of epochs. We can notice that the training loss starts to go down. The testing loss also starts to go down. And the accuracy on the training and test data set starts to go up. Now those are the trends that we're looking for. So an experiment you could try would be to train this model 0 for longer to see if it improved. But we're currently just interested in comparing results. So let's set up a plot. I want to plot model 0 results and model 1 results on the same plot. So we'll need a plot for training loss. We'll need a plot for training accuracy, test loss, and test accuracy. And then we want 2 separate lines on each of them, one for model 0 and one for model 1. And this particular pattern would be similar regardless if we had 10 different experiments or if we had 10 different metrics we wanted to compare. You generally want to plot them all against each other to make them visual. And that's what tools such as weights and biases, what TensorBoard, and what MLflow can help you to do. So I'm just going to get out of that, clean up our browser. So let's set up a plot here. I'm going to use matplotlib, going to put in a figure. I'm going to make it quite large because we want 4 subplots, one for each of the metrics we want to compare across our different models. Now let's get number of epochs. So epochs is going to be length, or we'll turn it into a range actually. Range of len model 0 df, so that's going to give us 5. Beautiful, range between 0 and 5. Now let's create a plot for the train loss. We want to compare the train loss across model 0 and the train loss across model 1. So we can go plt.subplot. Let's create a plot with 2 rows and 2 columns, and this is going to be index number 1 will be the training loss. We'll go plt.plot I'm going to put in here epochs and then model 0 df. Inside here, I'm going to put train loss for our first metric, and then I'm going to label it with model 0. So we're comparing the train loss on each of our modeling experiments. Recall that model 0 was our baseline model, and that was tinyVGG without data augmentation. And then we tried out model 1, which was the same model, but all we did was we added a data augmentation transform to our training data. So PLT, and we'll go X label, they both used the same test data set. And PLT.legend. Let's see what this looks like. Wonderful. So there's our training loss across two different models. So we notice that model 0 is trending in the right way. Model 1 kind of exploded on epoch number, that would be 0, 1, 2, or 1, depending how you're counting. Let's just say epoch number 2, because that's easier. The loss went up, but then it started to go back down. So again, if we continued training these models, we might notice that the overall trend of the loss is going down on the training data set, which is exactly what we'd like. So let's now plot, we'll go the test loss. So I'm going to go test loss here, and then I'm going to change this. I believe if I hold control or command maybe, nope, or option on my Mac keyboard. Yeah, so it might be a different key on Windows, but for me, I can press option and I can get a multi-cursor here. So I'm just going to come back in here, and that way I can backspace there and just turn this into test loss. Wonderful. So I'm going to put this as test loss as the title, and I need to change the index. So this will be index 1, index 2, index 3, index 4. Let's see what this looks like. Do we get the test loss? Beautiful, that's what we get. However, we notice that model 1 is probably overfitting at this stage, so maybe the data augmentation wasn't the best change to make to our model. Recall that even if you make a change to your model, such as preventing overfitting or underfitting, it won't always guarantee that the change takes your model's evaluation metrics in the right direction. Ideally, loss is going from top left to bottom right over time. So looks like model 0 is winning out here at the moment on the loss front. So now let's plot the accuracy for both training and test. So I'm going to change this to train. I'm going to put this as accuracy. And this is going to be index number 3 on the plot. And do we save it as, yeah, just AC. Wonderful. So I'm going to option click here on my Mac. This is going to be train, and this is going to be accuracy here. And then I'll change this one to accuracy. And then I'm going to change this to accuracy. And this is going to be plot number 4, 2 rows, 2 columns, index number 4. And I'm going to option click here to have 2 cursors, test AC, and then I'll change this to test AC. And I'm going to get rid of the legend here. It takes a little bit to plot because we're doing 4 graphs in one hit. Wonderful. So that's comparing our models, but do you see how we could potentially functionize this to plot however many model results that we have? But if we had, say, another 5 models, we did another 5 experiments, which is actually not too many experiments on a problem. You might find that sometimes you do over a dozen experiments for a single modeling problem, maybe even more. These graphs can get pretty outlandish with all of the lines going through. So that's again what tools like TensorBoard, weights and biases, and MLflow will help with. But if we have a look at the accuracy, it seems that both of our models are heading in the right direction. We want to go from the bottom left up in the case of accuracy. But the test accuracy, that's training. Oh, excuse me. Is this not training accuracy? I messed up that. Did you catch that one? So training accuracy, we're heading in the right direction, but it looks like model 1 is, still overfitting. So the results we're getting on the training data set aren't coming over to the testing data set. And that's what we really want our models to shine, is on the test data set. So metrics on the training data set are good, but ideally we want our models to perform well on the test data set, data it hasn't seen before. So that's just something to keep in mind. Whenever you do a series of modeling experiments, it's always good to not only evaluate them individually, evaluate them against each other. So that way you can go back through your experiments, see what worked and what didn't. If you were to ask me what I would do for both of these models, I would probably train them for longer and maybe add some more hidden units to each of the layers and see where the results go from there. So give that a shot. In the next video, let's see how we can use our trained models to make a prediction on our own custom image of food. So yes, we used a custom data set of pizza, steak, and sushi images, but what if we had our own, what if we finished this model training and we decided, you know what, this is a good enough model, and then we deployed it to an app like Nutrify.app, which is a food recognition app that I'm personally working on. Then we wanted to upload an image and have it be classified by our PyTorch model. So let's give that a shot, see how we can use our trained model to predict on an image that's not in our training data and not in our testing data. I'll see you in the next video.